Hey guys, in today's lesson we're going to go ahead and continue working on our half angle formula, and I want to go ahead and develop the tangent formula for the half angle. Just a lot of people have been asking for that, just so you guys can have it. So we'll start off with this one. We know that sine of the half angle is given for this, and we know the cosine of the half angle is this. And so when we do the tangent, we know it's sine divided by cosine. So I rewrote it right here, and then I use that to go ahead and rewrite it with the square root here of what I know is the half angle on the top and the bottom. And then I know that when I do that, since they both have a square root, a radical, okay, then we know the whole thing has a radical, all right? And then so that becomes my first, okay, my first half angle formula. So I'm going to use that one, okay, here and to develop the other ones that I showed you. So the first thing I'm going to do is I'm going to multiply by the conjugate. Okay, you see here 1 plus cosine, I multiply by 1 minus cosine. When I do that, this is like multiplying a difference of squares. Okay, remember that? Difference of squares. And you end up with 1 minus cosine squared of x. On the top, on the numerator, you end up with 1 minus cosine times 1 minus cosine squared. Well, if I take the square root on the top and the bottom, the square root on the top is just going to leave me with 1 minus cosine. But here, 1 minus cosine squared, I can use my Pythagorean identity here and substitute sine squared of x. And that's how we get this part. Well, if I take the square root on the top, like I said, I end up with 1 minus cosine. And the square root of sine squared of x gives me just the sine of x. And that becomes our second identity for half angle. And then the next one, I use actually the second one here. And what I do now is I multiply by the conjugate on the top. 1 minus cosine times 1 plus cosine. So you do it on both. And on the top you get 1 minus cosine squared. You use your identity again right here. Okay, substitute. And then you end up with this on the bottom. Well, one of the signs is going to simplify out and you end up with sine of x over 1 plus cosine of x. So understanding those and how you derive them, how to use them, it's helpful. Especially those of you that are moving up to the higher mathematics, because it's a lot of algebraic manipulation. And I just want you guys to understand how to use the conjugate and where we get all these identities. But let's go ahead and solve some equations, okay? And just a few, okay? And I decided just to write everything out, and it makes it a lot easier as and quicker to understand it. So this is our question here, and we're gonna go ahead and solve it. Well, I start off with my half angle formula here. So you notice the half angle formula is this guy, and then the square is on the outside. And that's what you do. This is your half angle formula, and you square it. Okay, and then of course, when you square, the square and the square root are going to cancel out. You're left with this. The 2 and the 2 are going to cancel out, which is nice. You're just left with 1 minus cosine. Okay, now the thing about these is, remember, you always want to have everything in terms of the same trig ratio. You want everything in terms of sine or cosine. That way you can combine like terms. But if you notice, this guy is sine squared. Well, what I did is, well, what you can do is you can replace it using your Pythagorean identity. Okay, so sine squared is equal to this guy, so I replace it. Okay, see, now I just have a bunch of cosines around. You distribute the negative. Okay, that's important. Remember, you got to put it in parentheses because this is a binomial. When you distribute, you get 2 minus 1 plus cosine squared of x. Okay, 2 minus 1 is 1. Now when I get to here, this part, what you want to do is combine like terms. And when I see a cosine or a square, I'm thinking, okay, I'm going to have to factor. Well, I brought everything to the left. So 1 plus cosine squared of x, the positive one becomes a negative. Negative cosine becomes a positive. 1 minus 1 cancels out. So you're left with cosine squared of x plus cosine. So from here, use your algebra skills. You're going to factor out a cosine. And then you're left with this. Once they're factored out individually, now you just go ahead and set it up with your zero product property. Cosine of x plus 1 equals 0. So now we got to figure out the cosine inverse. So where is cosine 0? And remember, this guy is a what I call a corner point. So over here, this point is 0, comma 1, and this point is 0, comma negative 1. So cosine is 0 here at the top and at the bottom. So what are those angles? Pi over 2 and 3 pi over 2. And there it is. Okay. What about the same thing with negative 1? Same thing. That's another corner point, and that's actually going to be over here on the left, which is pi. Okay, so these are your 3 solutions for this equation. Not too bad. Okay, let's see if we can do this guy right here. Okay, again, half angle, what do I use? My identity here. Okay, sine is a negative. All right, what you want to do when you have these radicals, you want to isolate the radical and then square it. So the negative cosine x plus 1, you bring it to the right. So now this guy on the left is by itself. So then you can go ahead and square both sides. Okay, and the nice thing about that is the radical simplifies out. You got to square this side. Okay, so this becomes cosine squared x minus this times 2, because it gets doubled. Okay, so you should get minus 2 cosine of x plus 1. All right, and essentially what you're doing here is cosine x minus 1 times another cosine x minus 1. Here, what do? Cross multiply now the 2. Okay, you end up with 2 cosine squared of x minus 4 cosine of x plus 2. Great, now continue, combine like terms. So I'm going to bring this guy to the right. Okay, so you rewrite it, then the negative cosine becomes a positive. Positive 1 becomes a negative. Nice. So now we could combine stuff that we can see. So what do we see? 2 take away 1 is 1. Negative 4 plus 1, that gives me negative 3 cosine. From here, notice the quadratic type. We're going to let u equal cosine. We end up with a quadratic. When you factor it, you should get 2u minus 1, u minus 1. Then you get u is equal to 1/2 because you solve it. U is equal to 1. Okay. Now we go back to cosine. Cosine x equals 1/2 and cosine x equals 1. So when you do your inverse, where's cosine equal to 1/2? Well, remember, use your hand, 1/2. Well, let's see here. We want one finger on the cosine. Okay, cosine is the top. So let's see. If I want one finger on the top, you have to bend this guy so there's one finger on the top. Well, what angle are you bending? You are bending 60 degrees. That is pi over 3. Okay. And then where else is cosine positive? Okay. All sin ta goes. So you have 2 places, here and here. Okay. I just draw it over here. This is pi over 3. Okay, well, what's this one over here? 3 take away 1, that's 2 pi over 3. Well, how do I figure out the one in the 4th quadrant? 2 plus 3, that's 5 pi over 3. Okay, so that's how we do it. So that's how I know it's pi over 3 and 5 pi over 3. What about here? Where is cosine equal to 1? And that's your corner point. Okay, where is cosine equal to 1? Well, this is your unit circle. This point here is 1, comma 0. And there it is right there. That's your cosine. So what angle is that? That is 0, or also called 2 pi. All right, guys. So that wasn't too bad. Let's do one that's a little bit harder. Number 3, the last one. All right, let's do some tangent. And this one I just made it up, and it came out a little, not a little messy, but just a little tedious and long, but same process. So let's go ahead and use the tangent. And here's my identity here. Okay. So now, same thing. I want to move these guys to the right. Okay. You square the square root here on both sides to get rid of the radical. And then over here, same thing. Now, negative cosine times negative cosine gives you a positive cosine squared. And then negative times negative is a positive times 2, because you got to double it, gives you 2 cosine x. And then negative 1 squared is positive 1. Okay, so that helps me out a little bit. Well, here now you're going to have to go ahead and cross multiply. So that's what I did here, 1 plus cosine x times this expression here. And we're just going to have to go back to Mr. Foil. So 1 times cosine squared is cosine squared. 1 times 2 cosine x, 2 cosine x. 1 times 1 is 1. And then you move over to the cosine. Cosine times cosine squared is cosine cubed. Cosine times 2 cosine x is 2 cosine squared. Cosine times 1 is cosine. So you're just doing a bunch of distribution there to everything. And you guys should be able to do that. Now that I have this, let's go ahead and move this guy over to the right. So we have, well, before that, let's go ahead and combine. Let's see here. We have a cosine cubed, and then cosine squared, and then 2 cosine squared gives me 3 cosine squared. And then 2 cosine x plus another cosine x gives me 3 cosine x. And then the plus 1 is just there. Now that we've combined that, we're going to go ahead and bring this guy across. Positive 1 becomes a negative 1. Negative cosine becomes a positive cosine. And then we combine. So this guy stays the same. And then 3 cosine x plus another cosine x gives me 4 cosine x. 1 minus 1 simplifies out. Now you get to this part, what do? You factor out a cosine. And you're left with this quadratic inside. Well, for this quadratic inside, we're going to have to use u substitution, see if we can factor them out. And then we're left with this guy. So u squared plus 3u plus 4. The problem, if you can see, it's not factorable. Well, so what do? Well, there's two options. One is complete the square, or the other one is quadratic formula. So I decided to use the quadratic formula. And that's your a, that's your b, that's your c. Okay. So if you notice, negative b squared minus 4ac. The only problem here ends up being 9 minus 16. That gives you a negative 7. You can't take the square root of a negative. You're going to end up with an imaginary solution. So we're done with that guy. So here, cosine of x equals to 0. You solve it. Where's cosine 0? We did it already at pi over 2 and at 3 pi over 2. Okay. So just a few examples. I wanted to go from kind of easy to medium to kind of challenging, just to kind of prepare you for what your professor is going to expect from you guys. Because some of these, as you can tell, takes up the whole paper and the whole process. But hopefully that helps, guys. See you guys next time.